In this video, we'll be going through piles and pile caps in RISAFoundation. We're starting out with a model that came in from RISA 3D. There's joint reactions here, and I've laid out a slab already. Below this has a slab with pedestals. We can see this in isometric view. And on the upper portion of this model, we're going to be doing pile caps. So piles will be going underneath the slab. So starting out, let's look at the pile definition spreadsheet. I'm going to open that up on the data entry toolbar. And we can see that in here we have all the information on the geometry of this pile. So we have a pile 1 or a pile 2. We can create an additional pile just by pushing enter. We'll use this first pile. It's a round pile. We're going to tell it the geometry, which is 12 inches diameter. The pile embedment is going to be 4 inches. That's fine. And what we'll also see is that really what a pile is it's a boundary condition. So it's going to be able to, we're going to have to define the capacity of the tension, compression, and shear, as well as the stiffness of this boundary. So is it rigid, or is it, we can give it a spring constant right there. So we have rigid for our compressive, our shear, and we're going to leave our tensile 0. So we're going to use those in this model here. I'm going to go ahead and take the rendering off. And we're going to lay out piles underneath this slab. So to put piles in, you're just going to go to this icon here to do the supports. And we tell the program here pile. We'll use that first pile there. And I can just either click on a grid intersection, or I can box at grid intersections, and we will get piles at those locations. Now once I've laid out those piles, what we can do is look at that in isometric view and see that those are right below the slab. I'm going to get this more rendered here so we can see that closer. So the loads are coming in from the top of the slab, and we have some pedestals above that, and then the piles are what is going on below that slab as support. For the joint reactions of over here, what we're going to do in that case is we're going to lay out pile caps. Now pile caps are just going to be a collection of different piles with a cap situation. So again, we have to tell the program some of the information, the basics, the geometry, and the properties. So first is the minimum and maximum steel ratio. We're going to be designing this cap. So we're going to tell the program that minimum and maximum. The material, we're going to say it's going to be 4,000 normal weight. Design rules. So we'll have to tell the program what type of reinforcement to be using. So if we go to our design rules, we'll see in here there's a footing and a pile cap there. And so what we see is we can do a top bars and the bottom bars, telling the program to use number 6s for top and bottom. If there's any overburden, we can put that in right there. The geometry of this pile cap can be defined. Now, there are some preset definitions for the piles. They're going to have a number of piles, and it's going to be preset for its configuration. So let's take a look for what that looks like. If you open up the help with the F1 key, we can see that the configuration of these piles, based on how many piles, is coming right out of the CRISI design manual, and that shows us the different pieces here. We're going to be using the 3 piles configuration. And so the way we're going to do that, if I close that out, we're going to tell the program 3 piles. And then we will want to tell the program the spacing factor and the edge distance, as well as what type of pile to be using. We'll use the same number 1 pile that we used previously. The cap thickness would be something we need to tell. With 24 should be okay. If there's a construction tolerance there, that's 3 inches right there. And we can reduce the capacities of the axial and the shear there of that pile if we needed to. So what we'll also go to take a look at the pedestal. Right now our pedestal on this pile is going to be 12 inches, but let's make it 18 inches in height, so a little bit shorter. So with all that defined, what we can do is go ahead and lay out our pile cap by just clicking on the support type one more time. And we're going to click on pile cap this time. Using pile cap, I can just say apply, and I can just select those 2 nodes. Now, if I look at this in isometric view, I can then see that there's pile caps located there with the 3 piles that we indicated below it. So what we'll do now is just run the solution. So I'm going to solve all the different load combinations we've already created, and it's going to run through a solution. And we're going to see here a little bit about what results we get. So in plan view, let's take a quick look. So under results, you have some pile cap results. Let's take a look at that first. It's a spreadsheet giving us all the information on the pile checks. It tells us the information on the unity check, gives us the unity check for compression, for shear. There was no tensile force there. Gives us our punching shear. Gives us the breakdown on the geometry, as well as gives us the steel reinforcement, tells us the pedestal steel, the cap forces, tells us a little bit more information about what's happening in the cap, and then pedestal. Now, that's a spreadsheet format, which is great for reports, but I like to also see is the detail report. So I'm going to click on the detail report for current item. And this gives us a really nice graphical view. So it tells us exactly what the layout of this pile cap looks like. We can see the pedestal on top of there. And then it gives us the pictures of reinforcement, showing us the pedestal rebar plan. And as I scroll down, I see the geometry. This is very similar to a footing, what we might see for a footing design, giving us all the information. The capacity checks there shows us again, this is what we just saw in the spreadsheet format. If we scroll down below that, we look at our reinforcement and the area of steel that's required versus the area of steel that's provided. And then we can see punching shear. We get punching shear for not only the pedestal, but also for the piles. Okay, a little bit different than footings. As we scroll down below that, we see the punching shear geometry. It tells us whether it was interior or corner for those pedestals and for those piles. And then one thing that's unique to pile caps is going to be one-way deep beam shear check. So we can see that the results of that shear check. And then we get our pedestal design below that. So this is all our detail report listing out exactly what's happening on that pile cap. Now for the lower portion here, this is a slab. So what we'll get is some slab information, but for the piles themselves, their results here are going to be under the pile results. So if we open up that pile results, we can see what the node label is. We might want to turn that on so we can see a little bit corresponding. So node 11, node 18, for example. Those pile results will give us this. Now this would be similar to a boundary. We're seeing the unity check, but we're also seeing what the force is listed in that pile. So we're going to see compression unity check with the compressive force in that pile, and then any of the governing load combination. We're going to see punching shear checks, so we are doing punching shear checks for these piles. Again, you get to see what the interior, if they were exterior, considered there. And we also see the unity check for these punching shears, and then the geometries, so we can actually break down the calculations of those punching shear. So to get really reinforcement in the slab, this is just like any other slab. You can do a design strip on the slab. So what we do is click on the design strip, tell the program horizontal, and we would select a section or strip of this so that we maybe can get the design on that horizontal cut here. So I'm going to cut that right across here and just double click it, and I get reinforcement across this top section. I'm going to go ahead and cut this right across down here as well, and we'll see I get reinforcement in that direction, top and bottom. Number 8's on the bottom, number 5's on the top, and I'm going to go ahead and use the design strip in the vertical direction, and I could get the reinforcement here, maybe a smaller strip here, and I can see that I'm using that right there, and I'm going to go ahead and cut this across this vertical strip right here. Click one more time, and I get that reinforcement for the slab. So we can see that we can do it two different ways. If you can't use a pile cap, the applying individual piles helps you do that more manual and in the different situations, but you get results here for reinforcement in both situations for your slab versus in your pile cap. And that concludes this video.